Hey everybody, welcome back to Uptime. We have another great episode for you this week. First off, the companies involved with insuring renewables think covering lightning damage is too risky and they may drop coverage. Rosemary, Joel, and I discuss the reasons behind this move. Then we review a new idea from Swedish-based wind project developer Hexicon, who thinks the future is building floating wind platforms like Ikea builds furniture. And then Joel and I have a chat with Morten Handberg of Wind Power Lab about inspecting blades at the factory before they are shipped to prevent costly repairs and delays at the job site. Stay tuned. We'll be back after the music. All right, guys, so the insurance companies that insure wind turbines for lightning damage are getting a little antsy about it and are starting to do two things that I've seen lately. One, really push operators to keep their wind turbine blades, lightning protection systems actively working, like verified everything's up in order. And second is they're pushing back on the OEMs because they're paying out too much money in lightning claims. And there's a recent article from Robert Bates, who's the head of claims for Nardak, and Nardak is a insurance broker. And they've looked at a number of lightning strike damages to renewable projects, which includes wind turbines. And so they wrote this piece describing what the real root of the problems are and what the industry is likely to do. And I think what the industry is likely to do is the interesting piece of this. So what Robert says is that lightning activity is expected to increase by about 12% for every 1 degree Celsius of warming. And they figure the United States could see a 50% increase in the number of lightning strikes. I've seen differing opinions about that, but let's just take that for what it is. And Rosemary, as you well know, as blades get longer and longer, they eventually add carbon fiber to them to stiffen them up. So as the turbines get taller, they're getting struck more often, and they're becoming more of a target for bigger lightning strikes. So one of the major insurance claims, is lightning damage. So what does an insurance company do? Well, they're trying to figure out how to de-risk this. And since the projections are 50% more lightning strikes, that means 50% more damage. That means 50% more payouts. That's not a situation where the insurance companies want to be. Well, what they're basically saying, and what Robert is saying is, and I don't want to summarize this for him, he can speak for himself clearly, but everybody go read that article, is that there's going to be much more pushback in the contracts, and there's going to be much pushback from the insurers onto the OEMs to the point of maybe not insuring some wind turbine operators based on where the farm is. Now, that's new. I've heard of them not insuring certain types of wind turbines, and I think that will continue on. There's certain types of wind turbines they do not want to insure for lightning because of the issues. But if they're trying to take some of the risk off of the insurance companies and put it onto the operators, that's not really a workable situation. And to summarize the article, what Robert's trying to get to is that there's going to be more reliance on international standards like the IEC standard to verify that the lightning protection system is working, and also more emphasis on basically maintaining the system. So, as we have seen recently on TikTok, Rosemary, and on YouTube, there's been some pretty visually interesting lightning strikes to wind turbines that have got a lot of eyeballs. Does the industry, the OEM side, start to step up and take more of a lead in the lightning protection system instead of relying on international standards? Or does the insurance companies finally step in, like they have done in many other industries, and say, we're not going to pay for this, tough luck, you guys figure it out? And Joel, you close on the RCA side. Are you seeing less activity, more activity on the insurance side? Are the insurance companies getting more involved into some of these claims?
I think what I see and what we're seeing on the insurance side in wind is that you're starting to see a lot more of the insurance companies lean towards this insuring wind turbines is a specialty insurance. Of course, we all know it's a specialty insurance.
Sure.
But more along the lines of really specialty. So more due diligence along what kind of blades do you have. Whereas before, when they like, I know like certain insurance companies, they just did market grabs. We're going to soak up all the renewables we can.
Right.
They didn't look at the condition of the blades, the design of the blades, the model of the blades, the age of the blades, all these different things. You know, is the asset owner a prudent operator?
Oh.
Are they maintaining them properly? Have they tested the LPS systems? You know, is there a bunch of leading edge erosion that could be, you know, causing lightning attraction in the wrong places? Those kind of things weren't thought about in the past, and what we're starting to see from our side as a blade consultant company is more and more insurance companies are diving deeper into the blades to make sure that they're taking on quality risk instead of just a large book of risk. Let's take on some quality risk because I mean the number that was out in 2019 was 3,800 roughly blade cases in the world that year. And at that point in time, there was about 400,000 turbines worldwide. So you figure 0.1%, if we go by number of blades, 0.033% of blades are affected. So that's statistically, you can count that. Now, if you want to get quality risk, you find the ones that have the best LPS system, take those on. If they have bad LPS systems that you don't like, don't take those on. And then what are the asset owners actually doing? Are they actually maintaining them? What does it look like? What does their maintenance program look like? So the insurance companies, from our side, you're starting to see the insurance companies step up and force the asset owners here in the next few years to be more prudent and provide better records of how they've maintained their blades.
And Rosemary, on the blade design side, and you were involved in de-icing or anti-icing of blades. It's probably one of the most difficult things to do in the blade world, but you're also involved with structures. The lightning protection systems on these blades really haven't evolved very much since I remember some of the first designs back in the early 2000s. With the addition of carbon fiber, is there really a lot of differences on the lightning protection systems?
Yeah, I think so. I mean, so I never really... I barely worked with lightning protection until I worked on a carbon fiber blade. Before then, the rule was just don't put anything conductive, past, I don't know, 10 or 12 meters into the blade. Like you can't go very, very far. And even, we had these incredible long list of things that you couldn't put in there, in case there were like traces of the factory workers all had blue markers or red, not black, because of some, I think there's some graphite in the black ones, and, that could attract lightning and, stuff like that. They really just, the rule was just nothing conductive in the blade except for the lightning cable.
Wow.
And that was a very simple and not always easy to follow, but it was very clear what the policy was. Definitely rules out a lot of options for de-icing though, for blade heating. And then when we needed to change to a more effective blade heating system, because if you can't put anything conductive out in the blade, then it rules out any like resistive heating type system.
Right.
So it was just when we were using a hot air system, and you have all the fans are metal, and all the electrical connections are obviously metal. So they would all be in the blade root, and by the time that the air gets out to the tip, it's not as hot. And there were lots of other challenges associated with that system, keeping all the ducts and everything in good condition for the whole life of the blade. So when I worked on a blade with some structural carbon fiber, and we were using a carbon fiber resistive heating system, then my project became much less like it used to be. My project was to design a heating system for a blade, and I really felt like on that blade, my job was like the heating system was 90% lightning protection and 10% heating, as like the heating was an afterthought because the lightning protection was so complicated. Yeah. And I don't think I can get into the details of how we solved these problems, but certainly it did not look anything like the old traditional design where you have a receptor, like a big chunk of copper or something, like a hockey puck of copper right at the blade tip, and a big thick cable conducting electricity all the way down the length of the blade and connecting it to the tower and the ground. That's how it used to be, and the new system was at least 1,000,000 times more complicated than that, in my opinion. It gave me no end of headaches, and it's also one thing to design it, but then another thing to make it. And because when you've got the carbon fiber, the lightning, it always wants to jump over to other conductive materials. Sure. And you're trying to stop it, so you put an insulator in between them. But there's a difference between an insulator that you test in the lab on this small scale that's perfect and has never been flexed. It hasn't gone through a million loads of being loaded and unloaded. So then you put that out in the field, and suddenly it's got some manufacturing defects in it, as every wind turbine blade does. And it's got some, small damages, as every wind turbine blade does, and then things start behaving differently. And I think that it's because we've had this huge change in what the system is trying to do now, that it took some time to get the real world experience and to learn how your design needed to be. You just can't do that in the lab and come out with a perfect system the first try. No. But already before that, like in the industry, nobody really felt like the certification was enough, right? There's general idea, super easy to get a lightning protection certificate. Yes. Not very easy to get a blade that won't be damaged by lightning. Like, everybody is designing to their own internal standards that they meet the certification, but then they go beyond that based on field experience. So I think that, it's just the problem has become more challenging, and it's just not the new type of lightning protection systems are not quite mature yet. Right. In my opinion.
Pointing at that IEC standard for lightning, it actually leaves out some of the, I guess in some people's opinions, it leaves out some of the components that are needed to be certified too, as far as metadata around lightning. It stops at specific energy basically, and that's it. Where we need to be looking at some more things that aren't even certified or aren't even on the certification.
That's something that's so common. Like when I work on root cause analysis, RCA, you would think that you got a lightning card in there, you should be able to tell if was this damage caused by lightning strike. You never can, like almost never. It's so, I can't think of a time when I've worked on a project and it's like, oh yeah, well they've got a lightning card, so everything's clear. It wasn't installed, or it hasn't been checked for so long that who knows what it's telling
you're right.
you.
I think those lightning cards don't really tell you all that much. It's a great idea, but the implementation of it leaves a lot to be desired.
I think Ping is working on a better system, right? What do you know about that? You must be involved with.
Pretty deep into lightning sensor for them. Yeah, and from our perspective, having looked at a lot of lightning strikes to wind turbines, some of the smaller lightning strikes are doing the most damage. And lightning in the aerospace world, where I come from, and into the wind world, they're really similar in this way. Once the engineering standard has been written, everybody forgets about what the real physics are, because you have a standard and you assume that there's been a group of people going through this, and that they've all figured out how to create this worst case environment. But it's worst case for the situation they wrote it for when they're all around the committee table. What happens is technology is moving faster than the committees can keep up with it. Same thing happens in aerospace. So the lightning and the way lightning behaves, a little nuances start to become more of a problem than they were 10 years ago, because the technology is different. Aluminum aircraft and a carbon fiber aircraft don't work the same. I mean, you're just doing different things on them. Same thing exists on a fiberglass wind turbine blade versus the fiberglass with the big carbon spars in it. They just behave differently. I don't think the industry has figured out how to deal with all that yet. And Rosemary, you're right. I think the flexing is a huge issue. And what we test on the airplane world and also in the wind turbine world, we always test pretty much the ideal, a brand new blade airplane part, and show that it works the way we intended it to. The effects of aging are massively influential in terms of the types of damage you're going to see. And because we're about 10 years into this experiment, Joel, this is where we're at. So we're learning about what happened in, blades of design in 2012. What's 2022 now? What kind of effect are we seeing? We're not seeing the results we would have predicted in 2012. That's the part I think the insurance company is starting to get a little antsy about, is saying the evolution of lightning protection is not keeping up with the pace of blade growth. People like Rosemary are designing bigger blades faster than the lightning community can kind of keep up with it. And what are we going to do? Or is the insurance companies willing to take that risk, or are they going to return it to the OEMs? I think in some cases, the OEMs are going to have to eat it.
Yeah, exactly. I'm hearing from, I mostly work with developers and wind farm owners, operators, and I'm hearing that it's getting harder and harder to get lightning insurance.
Sure.
And then, so the concern of the kinds of clients that I have, it's number one, I mean, they don't want lightning, but almost more serious concern to them is you can never figure out whose fault it is. And that makes it really hard for insurance, because each party's insurance company thinks that it's not their responsibility. So you can have insurance between, the OEM and, I guess their warranty, not insurance, but their warranty. And then the wind farm owner's insurance should cover all circumstances. But if you don't know what the circumstance is, then both sides can argue that it's not their responsibility. And I think that, like, the first preference would be lightning protection systems that just worked and you never damaged a blade. But I think most developers would be pretty happy to just definitively be able to say whose fault is this, so that you could just insure it and get on with it. You accept that we're going to pay a higher premium for a while we sort out, the design of these new systems and how they age. But as long as you can insure, people don't really care that much.
So one of the things that we've been working on the last year or two is looking at those little nuances, those lightning strikes that seem weird and that are particularly damaging, and what's driving them. And I think we have some ideas on that. And it sort of evolves back into, or devolves back into, what we've learned out of the aircraft world too. It's just totally different. Once you get moving at the speeds and at the altitudes that wind turbines are at right now, you're kind of acting a lot more like an airplane than you were 10 years ago. And that's where everybody needs to take a step back, I think, and relook at the problem. It's the next couple of years are going to be really painful in the lightning protection community, I think. I think there's going to be a lot of pressure from the OEMs and from the insurance companies trying to get the problem solved, and we'll see how the industry responds to it. Interesting development, and this article is just highlighting that issue.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the UPTIME Tech newsletter at weatherguardwind.com/news.
Offshore wind in the Gulf of Mexico. There are an announcement by the U.S. Interior Department that they're going to be ramping up offshore wind energy right on the coast of Texas and Louisiana, so right in that sort of northwestern part of the Gulf of Mexico. And there's one of the sites is going to be 24 miles off the coast of Galveston, and Galveston's just south of Houston. And it's going to cover about 500,000 acres of a site and potentially power up to 2.3 million homes, which I think Houston is about 4 million people, 5 million people. That's a lot of big part of southeast Texas then would be covered by 2.3 million homes. And the second project could be in Port Arthur, which is near Lake Charles, Louisiana, near New Orleans. And that's about a 200,000 acre site, which could power up to 800,000 homes, which would be most of New Orleans and the surrounding area easily, yeah. So this has implications just because of the timing of the announcement. Texas has been going through not blackouts, but they've been asking people to reduce the power usage during the daytimes, in part because of some maintenance issues that are going on, but also because the winds die down in the middle of the day, which I think is unusual. So if you look at the wind speeds and the amount of power produced from ERCOT, and you just go to the website ERCOT.com. It'll show you the solar and the wind combined, the renewable energy on the grid, the predictions and what's actually happening live. And you see that the winds actually slow down during the daytime. So the solar picks up where the winds slow down. So they're complementary. So the moving wind offshore sort of adds to that variability of energy sources. And we had a comment on YouTube, Rosemary, of all places. It was a comment from someone who appears to live in Texas and was upset about the fact that during the hottest part of the day that the wind wasn't operating as much power, creating much power. Therefore, they had to shut off air conditioners to get through that part of the day. But the energy company, ERCOT, knows that. And it's not that the engineers don't know. They totally know what that distribution looks like. But adding an offshore element to this would add a little more variability because it's also someplace
diversity.
Different. Right? Texas is a huge state.
Right? Like rather than...
Yeah, they're adding to diversity.
So that's a weird complaint to have, that you don't have enough wind in the middle of the day when it's really hot, because there is obviously another renewable energy technology that correlates very well with the hot days. So I mean, that's an easy solution, because solar panels are cheaper. If you can use the power when you generate it, then of course you want solar panels. So it just sounds like they haven't got enough solar in their mix yet. So I mean,
that's what it sounds like.
Yeah, that wind solves the harder problems usually. So yeah, it's interesting that they it's just a bit different to how I guess how things are tracking in Australia. We have the problems from too much solar and not enough wind, and it sounds like the opposite with Texas.
So I want to get to the energy diversity part of this, because they said our offshore wind has less variability as compared to onshore wind. And if you look at the power prices in Texas, the very tip of Texas, kind of around, I want to say Brownsville. Am I in the right general vicinity, Joel? Just at the very tip, bottom, southern part of Texas, the energy prices are much, much, much lower because there's a whole bunch of wind down there that doesn't get transmitted up to the rest of the state. So if you look at the power prices, it may be $1,000 a megawatt hour in Dallas area, which is sort of North Texas, but at the very tip of Texas, at the bottom, it's in the $100 a megawatt hour at the peak times. So it's a huge difference. So it's a combination of maybe not having enough wind, possibly needing to add some offshore wind, but also transmission lines seems to be part of the equation too. So Joel, does this offshore wind piece basically make Houston the renewable capital of the world, if it isn't already, if this happens?
Well, Houston right now, if you ask anybody in the tech world down there, they're touting themselves now as the energy transition capital of the world.
There you go.
As before, it was always the energy capital of the world.
Yeah.
And you're starting to see a lot of moves being made down there. What a better place to do it at? All those engineers down there. We've had tons of high quality offshore engineers in oil and gas and onshore engineers in oil and gas for years and years and years. And now they can make that transition. But so talking offshore wind right outside of Houston, I have quite a few buddies that fish down there. And they'll tell you, if I can get a day in the forecast where I'm at like 2 or 3 footers, 2 or 3 footers meaning 2 or 3 foot rolling waves.
Yeah.
That's the day I'm going to run out to the rigs and go fishing. That's where all the fish are. South of Galveston, that's 100 miles offshore. You start heading down the coast towards Mexico, it gets closer and closer and closer. So if the guys are going to run out that far, they wait for those 2 or 3 foot wave days. Now, a 2 or 3 foot wave day is easily on the surface fantastic and steady. And that's why we do on offshore wind, right? There's not the topography, there's not the change in temperature that you have onshore to create turbulent winds or intermittent winds. They're basically steady most of the time. So if they can install a big offshore wind farm there and then land a cable onshore to bring all that power to Houston and the surrounding area, fantastic. The thing I worry about, of course, we've talked about that before on the show, is Lake Charles got hit by 4 hurricanes last year. That's scary. Yeah. Because I don't want to wake up one morning and the beaches of Galveston be covered in blades.
In blades.
So that technology needs to be developed. Now, the rest of it, the other problems that exist in the U.S. for offshore wind don't exist on the Gulf Coast. You're not running offshore to deep water to do floaters like you're in California. Right. You don't have the regulatory environment on the East Coast, like the East Coast or like the West Coast. You have vessels down there that can transport jackets, and that's what I would build them with. that have been already doing it. If you, like I said, you can stand on the beach in Galveston with a set of binoculars and see platforms and rigs and jackets and stuff all over the place. The infrastructure out there is massive. So the ability to install, the workforce, the regulatory environment outside of federal is a lot better in Texas and Louisiana. So I think it's that hurdle of the weather that's going to be the problem, I think.
Well, this evolves into where wind is going to be developed, and offshore wind is going to be developed in the United States. And I know one of the Louisiana talking points is the wind farm off of Block Island. A lot of that was actually done in Louisiana. So Block Island is near us in Massachusetts, in the far northeast corner of the United States. But yet a lot of the steel and all the a lot of the technology at the time was done in Louisiana. So I think there's a little bit of a pride issue there. But just like with Australia, where everything's going to have to be shipped in, I think Louisiana is totally okay with just being a manufacturing factory site, and then just ship the foundations, the hulls, the floating, whatever, to where it needs to go. I think that's going to happen. Even in the Northeast, I think Louisiana is going to make a pretty good pitch to take over some of that work.
I would bet that you see even jumping the hurdles of hurricanes and the weather in the Gulf Coast. I would bet that you see offshore wind installed in the Gulf before you see it off the shore of California.
I think California is going to be a long haul just because of the regulatory aspects of it. And speaking of ingenuity in the U.S. Gulf, a company called Hexicon is talking about making Ikea-packs. And Rosemary, you're an Ikea user, right? I mean, you spent time in that part of the world where Ikea was everywhere.
Yeah.
You've got some Allen wrenches?
Yeah. Everybody has Allen wrenches from Ikea, don't they?
Yeah. Well, I didn't think they made the cut for the move back to Australia. The little, we call them Allen keys.
Oh, there you go.
In Australia.
Allen keys.
Yeah, and in Scandinavia, it's Ikea, not Ikea. So if you want to be that painful person that corrects your friend's pronunciation, like I'm being now, then you can whip that out next time.
I can see.
Next time someone says Ikea.
It doesn't really play well in America. It sounds like icky.
Yeah.
Sticky, icky, right?
Yeah.
Ikea is a better way to go on the branding there, I think.
Yeah. No, it's hard to avoid.
They make a mean Swedish meatball.
Yeah, I'm not so excited about their Swedish meatballs. But you usually, if you go there,
you don't ever go to the cafeteria?
Oh, I did on occasion. I came to really loathe that place because no one ever wants to buy their whole apartment of furniture from Ikea, right? Like,
true.
It's something that happens because you're like, I've got no storage in my bedroom, and at Ikea you can get a chest of drawers that precisely or pretty closely, they've got like lots of different widths, lots of different heights. You can much more easily find that random thing that will fit in the random space that you've got and get some storage in. But yeah, eventually I was like, I'm never going here again. It's just hell, they make you run that rat maze. You can't just get what you want. You have to.
It is like running a rat maze.
Yeah.
Yeah, it's brilliant marketing, by the way.
Yeah, and it's
psychologists
all just
on their team
to drain your energy so that you have to go buy the Swedish meatballs, which is where they make all their money off in reality, I guess.
That's what it is.
Add a little more energy so you can make it through the rest of the store. Yeah, exactly. I believe that.
You may only need that chest of drawers, but you end up walking past the bed and the cutting board and the drapes.
You know what? My favorite IKEA product, though, is this bamboo recipe book holder that it can either sit on the bench or it can sit on, like, hang off one of their rails. And yeah, like when you have a recipe book holder mounted on a rail so that it's right there by your stove, that's just life-changing. So yeah, I do appreciate that one product from them.
Well, you obviously know what an IKEA-pack is. It's those flat packages you get that are extremely heavy, and you're like, oh my gosh, how come will this weigh this much? Well, that same sort of philosophy is being applied to floating foundations. And the problem in the United States is, like, where are you going to make all these floating platforms that California is never going to make on their coastline because it's full of surfers and $100 million homes. So they're going to do it in Louisiana, pack them up into containers and put them through the Panama Canal to get to California. And I don't think this is a crazy idea. I think this is the way it's going to happen, because it's just going to be easier at the end of the day. Joel, don't you see the same thing? It's just going to be easier to pack it up and put it in Connex boxes and put it through the Panama Canal and be done with it, instead of trying, like, who's going to open up a floating foundation plant in Los Angeles? You think that's going to happen?
You're still going to have it. You still have to have a because where are you going to put together the IKEA box?
Mexico. No, I think Baja. I think it's going to be in Baja, right?
Why not do the whole thing in Baja? Bring the steel from Asia, which is cheaper, and build them in Baja and then float them over. I can see the concept and I like the idea, but it doesn't seem like a winner to me. It seems like it's too much work for, like, the juice isn't worth the squeeze.
I don't know. I think there's an artificial barrier, which is California, and everything's more expensive there. And maybe I think Mexico does make sense. I really do. That if you do it in Baja, it's great.
Now, if you take a container ship, like I've worked on, this is funny actually. I worked on an oil and gas exploration job where they brought a boat full of boats, and the ships were huge. They were 100 meters long, 14-meter berth, and they brought. Man, one of the jobs, they brought 8 of those on one ship. Offloaded them there. We did the job. They put them back on the ship, and they brought them back to France. So I don't see why they need to be packed down into Connex boxes. You could probably build 20 foundations and put it on a ship that can go through the Panama Canal and build them whole, where all you got to do is when you get to California, you could build them whole in Louisiana. When you get to California, put a tower on them, put the nacelle, the blades, quayside, and shoot it out there. I think that's a better idea of bringing less of them at a time, but bringing them almost wholly built.
Do you wonder if there's tax implications here? I think this is where this is going to revolve around, is the tax implications of where you assemble it. Like, how's California going to tax it? Because California has to tax it, right? And there's no way you're going to not build anything in California and not get taxed.
201 miles offshore California, outside of the exclusive economic zone. 2 boats, stack them, bring them in.
Yeah, I think you're right about that. I think that will totally happen.
I think people underestimate the amount of steel for that, though, too, right? So you're talking, when you're in 1,000 meters of water, mooring chains. Each mooring chain, like the general public doesn't see this, but I mean, like, massive, 2 of those mooring chains are the size of a car. Yes. Like, they're huge. So that amount of steel for these things the steel is not going to come from domestically. I can guarantee.
Never. Yeah. So I like the Ikea-pack idea. I like the idea of a focused manufacturing center in the sort of Texas, Louisiana area. Well, Alabama, isn't Alabama one of the steel states in America? Right? The Iron Bowl is one of the football games played down there because it's a huge steel manufacturing area. But they'll never make mooring chains there. I totally agree with you on that. It is an interesting thought process to see where it goes, because California at some point will have wind. But Joel, you're right. Texas and Louisiana will have a lot more wind installed before California does.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
I'm glad to have you back, everybody. This is Morten Handberg from Wind Power Lab.
Thanks, Alan. It's really great to be back at the show again to talk about blade issues.
So, Morten, you're the chief blade specialist at Wind Power Lab, and you are our resident blade whisperer. And we were talking a couple of weeks ago about what you're seeing on some blades. And the thing that came to the top during that discussion was manufacturing issues, that we're seeing more manufacturing issues, which I think probably related to the quantity of blades we're having to push out and just the pace of things, and it just makes it difficult in the factory. So there seems to be a little bit of manufacturing escapes. What kinds of things are you seeing out in the field when you go look at a blade?
As you know, it is still a handcraft to produce blades. So there is still a lot of manual labor and how do you say, manual tooling and workmanship going into these into the producing these blades here. So it is natural to expect a lot of variation inside the blades. But what we're seeing are some of them are, the old classics, void in the filler, where if you apply too much filler, then you will encapsulate some air, and over time that will then create some surface crack, reach to the surface, and then you will see it on predominantly the leading edge. We're also seeing finish works around the LPS receptors and around aerodynamic add-ons like VG panels or serrated flaps, where the sealant finish is sometimes missing, and sometimes it looks like it's just been applied, and then scraped around with the thumb, and then they left that part of it to someone else, and some of that can be explained just by that they are under a lot of pressure in hammering out these blades as fast as possible, and they don't have a lot of time to do it, and maybe not the required training in some cases. So then we're also seeing some more serious issues that we're seeing actually quite a lot, and more than I had initially expected. We're seeing a lot of missing adhesive and adhesive issues in general. And by missing adhesive, I mean that between the shear web and the blade shells, there is in a lot of the major manufacturers, there is an adhesive joint, and that adhesive joint is made by applying adhesive on the shell or on the shear web, and then the parts are compressed together, and then you press the adhesive out and ideally create an overflow. What we're seeing is that in some cases this insufficient amount of adhesive is applied to account for the thickness that is required, and then you see these air gaps or inclusions between the shear web and the shell, and that means that you don't have the necessary adhesive to transfer all the loads between the shear web and the shell, and that can be a huge structural problem for the blades.
Sure. Okay. So let's talk the air gaps here for a minute, because I've actually seen that. So, what causes that? Is it because as the tooling's compressed, it kind of lifts off and quote unquote breathes a little bit, so then it creates a void? Is that what's happening during the manufacturing process? Is constant pressure isn't applied, or it shifts?
Well, it can be two things. It can either be insufficient amount of adhesive applied, if it's a manual process instead of and not an automated one. So that's one part. The other one is that if insufficient compression is used, and the third variable is that every single blade is unique. So you will have variations from blade shell to blade shell, from surface to surface. So you can't necessarily be guaranteed that the adhesive that you expect to use on blade A is the same as you would use on blade B or blade C. There will be variations, and if that is not accounted for, then you will get voids. And it's not that big a problem, essentially, because you could actually fix it if you wanted to. If it's discovered during the post-processing phase, where the blade is being QA'd and checked, these areas are easy to identify because we can find them just by sending a drone in through the blade. We can see them clear as day. So any QC with sufficient time should find this without any problems at all. And then it would be a matter of reapplying additional adhesive to account for the missing.
A question, Morten, then, as this is kind of a science meets art, is what it sounds like, right? There's a process in place, but you need a good technician that's also going to make sure that everything gets applied properly. Have you heard of, in the marketplace, any places where they're starting to automate more of this? Because that's what it sounds like to me. You have, like, we're here in Texas. We have the big Tesla Gigafactory 2 hours away, and if you look at some of the LinkedIn posts and things they're putting out, the automation behind that factory is, next level. It's amazing. So I've seen whisperings of mechanical and robotic glue or adhesive appliers in some blade factories. But is anybody making big strides to say, guys, we have issues here. We know they're there. What can we do to solve them robotically or in an automation style?
Every single OEM has their own approach. So some would use resin infusion and RTM process to cast the entire blade, so you don't have any adhesive joints. Others, they have an automated system laying out the glass, the UD primarily, so that is done the same way each and every time. And I guess I think you're right that some also have an automated process for applying the adhesive, but it's not consistent. And no OEM, to my mind, have fully automated that the entire process. Everyone has something, but they haven't made the entire step. But they are still very heavily reliant on workmen, on technician skills to complete the task that they haven't automated. And so far, it's also cheaper to produce to do a lot of the processes by hand than by inventing and rolling out new heavy machinery.
Yeah, what comes to mind when you say that is the picture of the 115 meter long Siemens blade that's all over the internet, and like a row of 100 people standing down each side of it, and there's still all kinds of space, right? The project itself, the blade itself, is so big that to automate that entire thing would create a lot of robots. Or one big one, I suppose.
To the same extent, it also requires quite a lot of manpower to produce it, so it evens out.
Morten, what quantity of problems are you seeing out in the field? Because it seems like these would be very common issues in the factory based on the description of what the sort of the variables are here. So when you actually go out and look at blades getting installed into a new site, what percentage of them have bond issues or adhesive issues or other types of manufacturing errors?
I think, and I don't want to sound over dramatic, but close to 100% would have some kind of issue. Not all of them would require repair, but you would be able to find something in each and every blade. Which one would cause a problem further down the road, and which defect wouldn't? That can sometimes be sort of a risk management. You know, how risk adverse are you in your approach on what you want to fix and what you want to just stay as it is. But there are production deviations, I would like to call them, in every single blade. Some of them, and how many of them we would call out in for a repair or as in a warranty, that is not 100%. Some blades actually are passing through the test, but having said that, we still look at a majority within a wind farm where something needs to be done for every blade. So it is a serious issue, and some of it will then say, okay, this is actually an issue. You need to do something about it. But if you don't do something this year, you'll probably be fine anyway. But you should do something within, a reasonable amount of time to avoid having fatigue issues down the line.
Yeah, it does make a lot of sense. What kind of repairs would be made in those situations? Are they just basically replacing missing adhesive or grinding out a wrinkle in a blade? Are they sort of minor repairs, or are they really serious repairs where you're going to need weeks of time to correct them?
If you discover a manufacturing issue that hasn't evolved into a severe structural issue yet, it would often be a minor repair. So an adhesive gap that hasn't caused a debonding, that would just be reapplying adhesive and then you're done. So that would be a minimum amount of hours. But if it has already started to debond, then you're looking at a large scale repair, because you then have to remove or replace a large section of adhesive. And that is if you're lucky that it hasn't led to structural issues in the shell or the shear web before that. And we also see poor finish of the shear webs. And the shear web is a central part of the blade. And a lot of the OEMs, they use what is called a fish mouth finish, where they have this perfect half moon shaped finish of the shear web, and you'll be able to see an example of that in the on the YouTube version. But the reason why you do that is you want to distribute the strain, and the strain is the load of the local load over the blade, over the stiffness. That defines the strain that you have. And if you had a sharp finish of the shear web, then you would also switch from a very stiff structure to a less stiff structure, and that would create a large jump in the strain, and that is known to cause a lot of fatigue issues. And the OEMs found that the hard way many years ago, and so they introduced the fish mouth to smoothen out the transition of strain, so it wasn't a jump, it was a transition, and that proved to reduce the fatigue risk. But what we're now seeing is actually that sometimes these finishes are being ended with an abrupt step again at the end. It still has the fish mouth, but it doesn't have the complete transition. And we can see on some of the blades that we're seeing out there that actually causes fatigue delaminations at the start of the shear web. So that is also a severe issue. And luckily, we see that in less of the cases, but it's also a higher severity because it will lead faster to fatigue issues.
So is that a manufacturing issue in the cutout of the fish mouth, where they just don't get the right depth of cut into the fish mouth?
That is a manufacturing issue in the cutout and the finish of the fish mouth. That they cut it too soon, or they didn't start the profile at the right place. It can be difficult to say just from the outskirt looking at a picture, which is which. But the end result is the same.
Sure, and obviously it's a highly loaded and stressed location.
It's one of the most critical parts.
Right. It's right near the hub there. You would think that the inspections would catch that or have some sort of variability allowance, and if it went out, they would make some sort of repair. What can you do if it's not cut out properly? What are you going to do?
You could rebuild it, so you reestablish the transition that you want. You can do that by lamination. It does require some overlap into the existing shear web, but if you do that the right way, you can actually it can be done. Solutions are available out there for this kind of issue, and you want to do that before you actually see the delamination starting, because then you have to remove a lot more laminate than the prefix.
So then that gets at least to the question of blade inspections. Now, when I was down in San Antonio at ACP 2022, there was a lot of discussion on the floor about blade inspections at the factory or in the parking lot as you're leaving the factory or as they arrive on site.
If you can catch them.
Yeah, right. So they're moving so quickly now. What can be done?
One of the things that we ran into there, Alan, and I want to precursor Morten with this to think about as well, is I talked to some of the guys on the construction side, right? And the construction side guys are saying, I would rather you not do inspections here simply because I have to have these blades up by, July 1st. And if you start inspecting them on the ground here and I have to get a repair crew in, you're going to mess up all of my timelines. And if it's the small stuff like we talked about, you can get it done in a couple days. But a lot of times if there's something big, you might be there for a week or two on that set of blades or something. So just something in the background to think about while walking through this one.
I would always prefer that any owner factory QC of the blades is done at the factory, because then it's the OEM's problem to get it fixed before it's being delivered to site. Also, to your point, Joel, that they have also signed a contract to deliver blades at a certain date. If they've done that, then it doesn't really matter as much to them when the problem is being fixed. It really matters to them if it's captured at the factory, because then it really can't leave until that problem is fixed or a solution is found. So there is a high incentive for the owners to get it done at the factory. Obviously, that is what the OEM would least want, because that would mess up their production. That would create a bottleneck in their end, and I get that. But it's also where the most skilled technicians are located, so they would already have staff there that could fix it before it leaves. So I would strongly argue for that. The problem if you're doing it on site, and I would also recommend doing that, because you also have transport issues. So even if you have a perfect golden blade leaving the factory, when it reaches the site, you could have a large tremor in it. And if you don't capture that, then you'll see it a few years later when the shell is starting to detach. So you want to be ahead of that. And if you don't do it, and if you don't then discover some issues, then as you say, the construction team, they have a schedule as well. They have a crane that is moving around, and it's not going to wait for you to finish up repairing the blades. So then you could end up having to fix the blades when they're on the turbine, and then you lose availability. Obviously, it will always be a mix of the three, and that is fine. But I would strongly recommend that factory inspections are done at least once at the factory of every single blade. it would give a baseline of what is the condition of each blade.
So ideally, would you have it like a team of inspectors running around in the yard, or would you have it right when it comes off the line? There's a guy waiting with his clipboard.
I think to be fair to the manufacturer, then when the factory has said this is done, then you would go and check it before it leaves the lot. So when it's in the parking lot, essentially, that would be the right time to do it, because when it's being demolded, that might not give you the right. I mean, you would see a lot of interesting things, but it might not be relevant to you, because essentially, as a customer, you should expect that the blade you're getting is fit for purpose, right? So you don't want to go around checking every single step during the manufacturing process. That's not efficient for you or for the OEM. So you should trust the OEM that they're providing you with a fit for purpose blade, and then you check it before it leaves the factory. And the subset that doesn't fit that profile, you would then mark up the missing issues and then have it fixed before the leap. I think that would be the right process.
So that has a really interesting effect of possibly lowering the insurance rates for blades. If you're catching the large structural issues at the factory, you would think then once it gets out into service that it would reduce the warranty claims that are going to happen. Is there a push by insurance companies to ask for inspections at the factory?
They're not asking for it right now, but I think they're looking more in that direction, because they also want to see the owners and operators to take more responsibility. And I think we would see in the future that there would be a favorability of the ones who are prudent operators. So the ones who do show that they've been taking care of their asset from day one, the ones who check the blades at the factory, who know what the current conditions are, who have a maintenance strategy in place to see what is actually, what should I do with my blades and what is my history of damages. Because you will never be rid of damages over the lifetime of the blades. That is something we have to accept. But you need a good way to manage the issues that you have and not be surprised every time something gets damaged.
Yeah, I think that when we talk about the prudent operator idea, a lot of times my mind keeps floating to the construction site, but I've seen the person who's doing the receiving inspection is also the guy just taking off the straps and pointing them where to put the blade. Right, so having that proper inspector in the factory that knows the processes, that's been through them, that has the blade knowledge, I think is something not to be missed here as well.
And Morten, if you're walking up to a blade just brand new, and you don't have any knowledge of this blade previously, how long does it take you to look through the blade to check all the components and make sure all the bond lines are right? How long does that take?
So if you only check the bond lines and the surface structure, so you're checking for surface wrinkles, you're checking for missing adhesive, you're checking for finishing, then a blade up to 50-60 meters would take about half an hour internally, and the same externally. Obviously, if you want to do a more thorough inspection, that also includes checking the doing some tap testing or doing some ultrasonic, then you're looking more at a day per blade. And I wouldn't recommend doing tap testing of the entire surface. That's not efficient. That's only if you know where to look. But you can accomplish a lot by doing the basic visual check. Then you're in good hands with the majority of the issues. And then if you see that there is a lot of inconsistency in the adhesive, then you can argue for an ultrasonic inspection, because then there could be lungs or voids in the adhesive or between the spar cap and the shell. And they're also important to find, but then you do it based on an actual finding that you have. And I think that's more efficient than going straight forward with an ultrasonic straight away as an owner. I think a lot of the OEMs, they're actually doing it preemptively, and I think that they should continue doing that to make sure that their blades are in top condition.
Yeah, well, Morten, you've really raised a lot of interesting discussion here and things that I didn't know. I know inspecting in the factory or in the parking lot is becoming much more popular. I didn't understand why, and now it's pretty clear why that is happening, and it does seem like that's where the industry is going. I think that makes a lot of sense for everybody to at least consider it, because it will reduce warranty claims, downtimes, all those things. If you can catch it early, you always want to catch it early. So this has been a really interesting discussion. And I know you sent us a bunch of images that we're going to put in the YouTube version of this episode. So if you're not watching on YouTube, check out the YouTube version, because you'll see images and descriptions of all these things that Morten's been talking about today. So Morten, hey, thanks for being on the podcast again. Love having you on. I'm sure we're going to have you in the future. So thanks for being on this time.
It was a great pleasure. I'm looking forward to next time.
That's going to do it for this week's Uptime Wind Energy podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform of preference. Be sure to subscribe in the show notes below to the Uptime Tech News, our weekly newsletter, as well as Rosemary's 2 million plus viewed YouTube channel, Engineering with Rosie. And we'll see you next time on the Uptime Wind Energy podcast.